Welcome to the Sleepy Atomist. I'm so glad you found your way here. Perhaps you're already resting, the lights are low, the day has softened and quiet has begun to settle around you. Maybe you're bundled in warmth or simply resting your thoughts in the stillness of now. Wherever you are, this moment belongs to you. A calm pocket of the night where curiosity and peace can breathe together. Tonight, we'll float into one of the universe's most whispered mysteries. Black holes. Not with urgency, not in a rush of facts, but with the same ease two stargazers might wander aloud beneath the velvet sky, letting their thoughts drift softly into the stars. I've shaped this story to be slow and sleepy, a gentle unfolding, but black holes are wonder wrapped in gravity, and sometimes that wonder wakes the mind even as the body drifts. If your thoughts begin to swirl with questions, that's all right. Let them rise and fall like waves. If you're enjoying this gentle exploration, a soft like or a quiet subscribe means more than you know. And if you're listening from somewhere special, beneath the stars, near the sea, or in the comfort of your favorite chair, I'd love to know. I treasure the way our little map of midnight curiosity keeps growing. These stories are for rest and learning. They're not a substitute for sleep care, just a place to feel the universe slowly. So breathe, let go, and look up. Above you stretches an ancient sky filled with stars whose light began their journey long before your first breath. The sky hums, but not in sound. Space is not empty. It is stitched with gravity and time, shaped by presence and silence. The stars you see are old messengers. Some have already gone cold, their light still making its way to your eyes, each photon a soft echo from the past. And in the dark between them, where nothing seems to be, something hides. Black holes. They do not glow, they do not announce themselves, but they are there, silent as breath, scattered like unseen punctuation in the story of the cosmos. A black hole is not a thing, it is a place where gravity has curled so tightly that not even light, the universe's swiftest traveller, can escape. Formed when certain massive stars reach their ends, black holes are what remains after collapse goes too far. Most stars end quietly, becoming white dwarfs or neutron stars. But a giant star burning too fast dies in a brilliant supernova and collapses beyond stopping. Its core shrinks past atoms, past protons, past imagination, into a singularity, a point of infinite density, not a surface, not a solid, a silence wrapped in gravity. Even now, as you lie still, black holes move through our galaxy. They pull gently on things we will never see. And sometimes, rarely, two of them find each other. They do not crash. They do not collide with haste. They spiral, slowly, patiently. For millions of years they orbit, two shadows in motion, drawing closer with each turn. As they circle, they ripple space itself. These ripples are not sound or light. They are gravitational waves, distortions in the very shape of the cosmos. Imagine space as a soft silk stretched in all directions. Two black holes spin across it like heavy dancers, tugging the fabric with each step. The waves they make move outward endlessly. These waves are passing through you even now, too faint to feel, yet still real, like a hush stretched across galaxies. And as time passes, their spiral tightens. The dance quickens, the final steps begin. When they meet, they do not shatter. They melt into one, forming a larger black hole in silence. The energy of that moment doesn't shine, it ripples invisibly in the space around them. But that's not where we begin. Tonight is not about endings. It's about the gentle unfolding of movement and memory. Black holes do not rush. They follow the tempo of deep time. A single orbit may last 1,000,000 years. The universe is patient, and tonight, so are we. Somewhere far from here, two unseen giants are circling. They aren't fighting, they aren't racing, they are simply following a pull as old as gravity itself. You don't have to know every law to feel the beauty of that. Just rest. Let your thoughts orbit softly. Let your mind drift like starlight. Slow, unbound, free. And as this awareness deepens, a question emerges, quiet and vast. What is a black hole truly? Let's float there now. When you hear the word, maybe you picture a swirling tunnel or a glowing ring. But a black hole is not a hole. It isn't even truly black. It is gravity at its most pure, a region of spacetime so curved even light cannot leave. To find their origin, we return to the stars. Stars are born in clouds of gas, hydrogen gathering under the steady hand of gravity. As gas condenses, pressure builds and nuclear fusion begins. For billions of years, stars shine, balanced between gravity's pull and the outward push of heat and light. But eventually, the fuel runs out. Gravity waits. In smaller stars, collapse stops early. A white dwarf forms, but massive stars collapse further into neutron stars, or deeper still. If their mass is great enough, the collapse never stops. A black hole forms, and around it, the event horizon, the point of no return. Once something crosses it, even light cannot turn back. There is no edge, no wall, only a curved space where time flows differently. Inside lies a singularity where the known rules of physics dissolve. Yet black holes are not cosmic monsters. If the sun were replaced with a black hole of equal mass, Earth would still orbit, untouched, just in darkness. You could even approach a black hole and, from a safe distance, feel nothing unusual. They do not chase, they do not consume at random. They wait, and near them, time itself slows. Imagine holding a clock near a black hole while a friend watches from far away. To you, the seconds pass normally, but to your friend, your clock ticks slowly. Your voice stretches, your movements crawl. This is gravitational time dilation. It's not science fiction, it's real. Right now, your feet experience time just slightly slower than your head. Near a black hole, this effect becomes extreme. A few minutes near the event horizon might pass while eons slip by outside. Black holes bend not just light, but time. Still, we ask, if they trap light, how do we see them? We see their footprints. We observe stars orbiting empty spaces. We watch gas heat up as it spirals inward, glowing briefly before vanishing. We've seen X-rays and distortions, even the shadow captured in 2019 by the Event Horizon Telescope. They anchor galaxies, sculpt matter, and cradle silence. And sometimes they find one another. Two black holes drifting alone begin to spiral. Their motion is not violent, it is graceful. Their event horizons stretch, touch, and merge. No light escapes, but gravity speaks. Gravitational waves ripple outward, space itself stretching to carry the story. Let's follow those waves next. Think of space not as void, but as fabric. Flexible, alive with motion. In this fabric, black holes move like whirlpools, their orbits sending out ripples. These ripples aren't sound, they are shifts in the shape of space. With every orbit, a new wave is born. We are moving, they say. We are becoming one. Back on Earth, we don't feel them. They pass through us, smaller than a proton, quieter than thought. But they are there. And as the black holes draw closer, the ripples quicken. Their signal becomes a rising tone, a chirp. In 2015, we heard this chirp for the first time. LIGO, an instrument with arms kilometers long, measured the trembling of space itself. A whisper from 1.3 billion years ago had arrived. Two black holes had merged, and Earth had wobbled ever so slightly in reply. This was the first time we didn't just observe the cosmos, we felt it. The final spiral ends, the horizons merge. One black hole remains, the last wave stretches out, a farewell written in gravity. Even after the new black hole quivers, a cosmic bell ringing once before fading. This echo too becomes a wave, and then silence. So here you are, on a quiet planet, breathing beneath a story that began before Earth knew life. A dance in the dark, unseen, unheard, but real. Black holes do not shine, but their echo passes through you. Their merging is not an end, it is a transformation, and their story, told in ripples, still travels outward. What carries those waves? What holds space together in silence? Let's float gently there next, into the very fabric that cradles everything. Time feels so steady here, doesn't it? Soft ticking seconds, soft breaths, the rise and fall of your chest, the quiet rhythm of night laying across your body like a warm and endless blanket. But time is not what it seems. It's not steady everywhere. And the deeper you drift into gravity's quiet embrace, the stranger it becomes so. Tonight we lie at the edge of something ancient, a black hole, and we watch how time bends, not with a jolt, but with a slow, dreamlike stretch. Imagine floating near a black hole in space. You are safe. You're not falling. You're hovering peacefully just outside the event horizon, that invisible boundary where space folds and time begins to distort. You hold a clock in your hand. It ticks gently 1 second, and then another. Everything feels normal to you, unchanged, but far away. Your friend watches from quieter gravity in open space, and they see something strange. Your seconds lengthen your movements. Slow the light, reflecting off. You reddens, dims, becomes drawn out to them. Time moves faster, but to you, it still feels the same. This gentle bending of time is real. It's called gravitational time. Dilation, part of Einstein's general relativity, where stronger gravity makes time move slower, not as an idea, but as a fact. Time itself stretches closer to Earth's surface. Time ticks a little slower than it does in the sky. GPS satellites account for this every moment. And near a black hole, that shift becomes profound. If you hovered just above the event horizon, minutes, for you could mean centuries for your friend. You might return to a world, unrecognizable mountains, reshaped stars, born and burned out, and all you felt was a single breath between heartbeats. This isn't science fiction, it's tested, confirmed and deeply embedded in the way gravity works, and black holes show us its most dramatic form. But what if you cross the edge, you drift beyond the event horizon? Quietly, peacefully. There is no impact, no visible line, no sudden shift from your view. The fall feels smooth, but to those watching from afar, you appear to freeze, lingering on the edge. Your body stretches, not in shape, but in time. You become a memory stuck at the threshold until even your light cannot escape, and you vanish from view. Strange how time so familiar can break and bend and melt, but maybe that's what makes time gentle. It listens, it adapts, and in the presence of great mass, it grows patient. So tonight, as you lie still, maybe it comforts you to know that time isn't rushing. It can slow, it can breathe with you, and when the gravity is strong enough, it waits. Now, imagine 2 black holes just before they merge, spinning faster, closer, their combined gravity reshaping space itself, and near that swirling center. Time nearly stops the moment before they meet, stretches like a breath held just a little too long. But for the black holes themselves, there is no pause. They touch, they become one, their horizon. Reshapes, time resumes, and a soft, final ripple of their embrace travels outward, a gravitational wave carried across the stars like the faintest farewell. You lying still have always lived in time's river. It carries you gently from then to now, from now to someday. But black holes remind us that the river doesn't always flow at the same speed. It twists, it crawls, it can pause, and maybe that's what makes time precious. Not its speed, but its softness, its ability to hold memory and mystery and pause for meaning. What would it feel like to float above a black hole to rest, where time moves like syrup, thick and slow, where gravity bends the seconds between thoughts? Would you feel more present? Would dreams stretch out like distant horizons? Would stillness become a kind of truth? Maybe you're not near a black hole tonight, but still, time stretches a little for you. Not because the universe has paused, but because you have allowed it. You have chosen to slow your breath, to let go. And even though Earth still spins, you are allowed to float, to stretch seconds like silk. Because sometimes the most powerful act is to rest, to drift inside the gravity of now. But if time can slow, can it ripple? Can we feel those ripples? Can we measure the soft waves sent from a black hole's embrace? Let's listen. Next, let's learn how we first heard space. Tremble with memory. Somewhere in the night sky, a star is dying, and it does not cry out. It doesn't flicker with panic. It simply ends. It reaches the close of its long burning life. To understand black holes, we begin not in darkness, but in light. Because every black hole begins with a star. Imagine one now, massive, luminous, older than memory, its body made of hydrogen, its heart, a fusion engine burning for millions of years. It is not calm, its surface is chaos. But inside, a perfect balance holds gravity, pulls in fusion, pushes out, and for a time all is steady, but no fuel lasts forever. And as it runs low on hydrogen, the star begins to change, fusing helium, then carbon, then heavier elements, until it reaches iron, and iron takes more energy than it gives, so the balance breaks, gravity wins, the star collapses, its core caves in atoms, crushed protons and electrons squeezed into neutrons, light is trapped, matter folds in on itself, the outer layers erupt outward, a supernova brighter than galaxies for a moment, and then quiet. What's left depends on the star's size. Small ones leave white dwarfs, heavy ones become neutron stars, but the most massive of all fall further inward past resistance, past light. And a black hole is born not with violence but with surrender, where escape requires faster than light, and nothing escapes, not light, not time, not even memory. The event horizon forms a boundary, not of material, but of motion. Inside, everything falls toward a singularity, a point so dense our math breaks, and yet it begins not with destruction but with light, a story of change, a life too brilliant to remain contained. You may ask, how often does this happen? More than you'd expect in our galaxy alone. Millions of black holes lightly drift quiet, hidden, unseen, but real. Some are born of single collapsing stars. Others grow from many mergers. Some from colliding galaxies. They become giants, supermassive black holes, millions, even billions of times heavier than our sun. Nearly every galaxy has one, including ours, at the Milky Way's heart. 26,000 light-years from where you rest, there is a black hole. It spins gently, pulling stars into orbit, invisible yet undeniable. It has been there longer than Earth has had. Oceans longer than mountains have stood a silent anchor in the center of our spiral. Even now, above your head, stars burn. Some will fade. Others will end in collapse and vanish into black holes. Not with a bang, but with a fold, their mass remains. Their gravity deepens, and a new silence settles. This silence is full, not empty. It holds gravity, memory, the remains of light, once radiant, and someday another black hole may drift close, and they will orbit, spiral, merge, and send out not just the story of a star's death, but the memory of something new, born in gravity's arms. So you see, black holes are not monsters. They are memories, stories etched in motion, born in light, folded into time. And when they find one another, a new kind of conversation begins, not in light, not in sound, but in ripples. Imagine space as fabric, soft and invisible, normally still, but when massive things move, it trembles. When two black holes spiral, they disturb that fabric. They send out waves, not of air or water, but of space itself. These are gravitational waves. They stretch you briefly, then release you, smaller than an atom, quieter than thought, but real. When a gravitational wave passes through you, you grow slightly taller, then shorter. Again, you do not feel it, but it changes you. Ever so slightly, these waves are how black holes speak. They do not shine, they do not reflect, they merge, and in that dance they send space itself into motion, each orbit another ripple, and as the spiral tightens, the waves grow stronger, faster, a rising pitch, a crescendo, until the final embrace, and then the last ripple. The note travels outward, a memory, a vibration, a goodbye. You may wonder how we know how we could possibly feel something so faint, because we've built instruments that can listen to space breathing. LIGO, the Laser Interferometer, Gravitational Wave Observatory, listens with arms 4 kilometers long, shaped like an L. Lasers bounce within those arms, and when a gravitational wave passes, it changes the light pattern just slightly, and we detect it in that flicker is a story, a ripple caught and transformed into sound. In 2015, we heard our first chirp. Two black holes had merged over 1 billion years ago, and their final whisper passed through Earth, a soft rising tone, like a bird call in the void we had waited, and the universe answered. Since then, we've heard dozens of events, black holes dancing, colliding, telling their stories not in light, but in motion. Some are light, quick, some massive, slow, but all are real, each one a moment where gravity sang. Sometimes it's neutron stars merging, and those produce light as well, a duet of wave and shine. But the black holes speak only in silence and ripple, and from that silence we have learned to listen. These waves still travel now from collisions before humans walked, from stars long gone, and when they pass through us, we do not feel them. But LIGO might, Virgo might, and soon might. And Kagra and Lisa will join space-based listeners, drifting above Earth ears, stretched across the cosmos, listening, always listening for those quiet echoes of gravity. The best part is that these waves do not weaken. They cross galaxies. They whisper through stars. They continue on and on. You don't need to be a physicist to find wonder here, to pause and feel the quiet magic of machines that hear space itself tonight as you lie in silence, your body still, your breath slow. Remember this. You are sharing the world with instruments that do not sleep, with detectors that do not blink, and with black holes that speak without sound. And when their voice arrives, when that final wave brushes your planet and continues on, it brings with it the memory of something beautiful, the end of stars, the bending of time, and the gravity that holds everything together. Even your rest tonight, held softly by Earth, cradled in curved space, part of a universe that breathes and remembers. Now let us follow those waves a little further to the fabric that carries them gently forward. Let's float into the cloth of the cosmos. It has shape, it has depth, it has texture, and it can be moved. But what exactly is it made of? What is this fabric that trembles and flows? Let's drift there next into the soft curved cloth that holds every star in place. Close your eyes and imagine space, not as emptiness, but as something gentle, a fabric, a stretch of silk drawn across the cosmos, smooth, curved, dimly shimmering. This is space-time. It sounds abstract, but the idea is simple. Space and time are not separate. They are one connected field, and everything in the universe moves through it. Now, imagine that fabric flat and still. Now place a marble on it. The silk dips, a small curve forms around the weight. That curve is gravity. Now roll another marble nearby. It bends inward, not because the first marble pulled it, but because the shape beneath it guided its path. This is how gravity works, not as a force pulling across distance, but as the quiet curvature of space-time shaped by mass and energy. Einstein gave us this image that mass bends space, and space tells objects how to move. It's a quiet conversation. Here's the shape, says the star, then here's the path, replies the planet. And so the moon doesn't orbit Earth by being tugged on a leash. It moves along a valley in space-time like a marble circling a bowl, guided not by strings but by landscape. This invisible fabric stretches everywhere. It holds you to Earth. It keeps Earth circling the sun. It shapes galaxies and tethers the stars. Right now, this very moment, space-time lies beneath you, around you, within you. Your breath flows through it. Your weight presses into it. Every step you've taken has bent it just slightly. Even your body makes the tiniest impression in the cosmic sheet. Now think again of that silk. What happens when you place something massive on it? A planet makes a gentle dip. A star makes a deep well. But a black hole doesn't just dip it. Tunnels. It makes a slope so steep that nothing, not even light, can climb out. Not because light is weak, but because the path to escape no longer exists. Space has curved too far inward. There is no direction that leads out. This is why black holes are dark, not because they are hidden, but because light can't leave them. Yet even black holes do not tear the fabric. They stretch it, they deepen it, And when they move, like when two orbit each other, they send out ripples. Those are gravitational waves. You've felt them before in the chirps. Detected by LIGO, not sound, but gentle distortions of space itself. These ripples do not travel through air. They are the motion of the fabric itself. Space-time flexes, then recovers, then continues elastic, not like rubber but like water flowing, rippling, carrying motion across the universe, soft to touch but strong enough to cradle galaxies. Space-time is the most delicate strength you can imagine, a silent infrastructure that bends around planets and holds time within its folds. Scientists don't just speak of this as metaphor. They calculate with it, they rely on it. GPS signals must correct for Earth's curvature in space-time, or they drift within minutes. Satellites orbit where the fabric allows, and light curves where mass has left its imprint. So when you look at the stars, you are not looking into a void. You are looking across a structure, a soft, silent architecture that holds everything in place, that starlight that reaches you, it bent along its way, guided by the curves of space-time, its path shaped by everything it passed, and your path too is shaped by this cloth. Every fall, every orbit, every breath. Even now, as you lie still, you are drifting through space-time. Itself is part of the fabric, and you are always moving through it forward, gently, comfortingly, not floating in nothing but resting in a cosmic web, woven from gravity and geometry. And black holes, they are not holes at all, but dimples in that web, places where the fabric folds in on itself, where space-time keeps its secrets gently, quietly, completely. So next time you feel stillness, remember you are still moving forward through time, wrapped in curves, woven into something that holds stars and dreams. And you, and if space-time can carry waves, can it carry something more? Can it remember what falls into a black hole if a black hole swallows light? And matter, does it erase them? Or does the universe find a way to remember? Let's wonder about that. Next, far away in a patch of dark, between galaxies, two black holes circle each other, not quickly. Not yet, their dance is slow, ancient. The rhythm has taken millions, maybe billions of years to near its end. Each black hole bends space-time deeply. They orbit within one another's warps, tugging on the very fabric that holds them, and as they spin, they spiral inward, drawn closer, not by a force pulling, but by the shape around them. Shrinking space-time itself pulls them closer. In this final act, the giants move with grace, not violence. The space between them narrows the time near them, stretches thin, they circle faster, they fall inward, their spiral tightens. You know this dance, now you've heard the waves. It makes the gravitational whispers rising with each orbit, not in sound, but in motion. The universe begins to hum, and just before they merge, everything changes their horizons touch, not with a bang, but with a folding, a surrender. Their singularities fall into one another, and they become a single new black hole. And with that union, space-time shivers, the final gravitational wave expands outward, the softest yet most powerful exhale, and then silence, the new black hole quivers slightly. It rings not with noise, but with motion. Its edges vibrate like a bell struck. Once those final vibrations echo outward, the last whispers of the merger, and then all is still. That wave travels endlessly, crossing galaxies, bending stars, flowing through you, through the soil, through the sky, not with impact, but with memory. That's how we know the black holes have become one. We feel the ripple in space itself. LIGO listens, and when it hears the chirp, it tells us what happened, how massive they were, how far they danced, what they left behind. The wave tells the story, and it tells it without light, only with gravity. You may wonder what happens to the mass of the black holes when they merge. Do they lose anything? Yes, they do. Some of their mass becomes pure energy, not as heat or brightness, but as motion in space-time. In some cases, more energy is released in gravitational waves than all the stars shining in the visible universe. But we don't feel heat. We don't see light. We feel the shift, the flicker, the wave, and then it's gone. And yet it goes on, endlessly soft, endlessly vast. And so, as you lie, still know this. That final ripple is still moving through the cosmos, and others are forming now, again and again. Black holes merge, Stars collapse, space-time rings. The energy is immense, the moment is fleeting, the memory is permanent. You are part of it. You are lying in a quiet moment, touched by the echo of an ancient collision, and you didn't even notice, because the wave was kind, soft, precise, moving at the speed of light, but more subtle than breath. This is how the universe speaks. When black holes collide, they do not shine, they do not scream, they whisper in waves, and those waves travel through everything without asking for permission or notice. The waves carry no sound, but they carry story. And now you've followed one of those waves, you've felt the stillness that comes after the ring down, the bell that settles the black hole that waits, not broken, not burning, just present immense and still. It waits perhaps for another to pass nearby, perhaps forever, alone. It doesn't mind. Black holes are patient, the waves have passed, the memory remains, and the new black hole is quiet. It doesn't show where it came from. You can't tell what merged to make it. Whether it came from 1 star or 2 or 10, it looks the same. They always do, mass spin charge, nothing else. It's called the no-hair. Theorem black holes don't keep their scars. They don't tell their history. They just are. But the universe remembers in the waves, in the ripples, in the measurements. We record, the story is saved. Not in the black hole itself, but in the space. It shaped the motion it made, the wave. It's sent you have followed that wave now, and in doing so, you've joined the story. Stillness doesn't mean nothing happened. It means something vast has just become whole, and in that quiet something new waits, wrapped in the deepest geometry space, curled so tightly it keeps even light from escaping. And now, as you drift near sleep, let that stillness hold you. Let gravity keep you wrapped gently in the curves of space and time. Because even here in this soft moment, your atoms rest in the folds of space-time, the same folds that black holes stretch and stars bend and waves ripple through without end. And tomorrow, if you look up again at the stars, know that the space between them is not empty. It is shaped. It is alive with memory, and the night is not silence. It is structure, and everything is still gently moving, a hush that holds memory, a darkness that contains. And maybe as you drift off to sleep, you imagine yourself hovering near the event horizon, watching the slow fold of space settle into silence. No sound, no fear. Just gravity doing what it always does, holding, shaping, waiting. But before this black hole ever formed, before the light was lost, there were clues before it became a shadow. It lived as fire, as fusion, as a star. Can we see it now? Not directly, but we can find its outline, its influence, its whisper carved into space. Let's look for it next. You've followed the story this far. A star lived it, collapsed. It became something dense and strange. A black hole, heavy, quiet, unseen. Now your question rises softly. Can you see it? The answer is simple and deep. No, you cannot see a black hole itself. It gives off no light. It does not glow. It does not reflect once something crosses its boundary. The event horizon, it is gone. Its light pulled in forever. But yes, you can see what it does. Gravity leaves trails, it bends, light curves, orbits, shapes time. And in these subtle warps we glimpse the invisible. Imagine walking through a forest. The creature is hidden, but branches are broken. The air is disturbed. Something passed through black holes, leave these marks in the sky. One of the first came from a star called Cygnus X1, a star orbiting something unseen, its motion tight fast, as if tethered to an invisible weight. But nothing could be seen, only X-rays pouring from that part of the sky. High-energy light, coming from a place with no face. What we were watching was a star orbiting a black hole, and the black hole was feeding. When gas surrounds a black hole, it doesn't fall straight in. It spirals inward, drawn by gravity, compressed by friction, heated to millions of degrees, and before it vanishes, it shines. This glowing swirl is called an accretion disk, a ring of fire circling silence, a final bright breath before darkness. Takes the light, and though we cannot see the black hole, we can see this spinning flame. We can watch it flicker and flare just outside the edge. Black holes do more than pull. They bend, they curve the light around them. light from stars behind. A black hole is bent, distorted like glass, like heat over a road. This is gravitational lensing, the bending of light through curved spacetime. The black hole becomes a lens, not of glass, but of mass. And sometimes it creates a perfect ring of light around darkness, an Einstein ring, the fingerprint of something massive and invisible. So, no, we cannot take a picture of the black hole itself, but we can capture its silhouette, and we did in 2019, the Event Horizon Telescope. A network of observatories across the Earth captured the first image of a black hole's shadow in galaxy M87 55 million light-years away, a dark circle surrounded by glowing fire. Not the black hole itself, but its outline, the absence that reveals the presence. It wasn't a normal photograph. It wasn't taken in a moment. It used radio waves stitched across the globe, timed by atomic clocks and woven with patience. The result was soft, grainy golden. A ring with a dark center. Not an eye, not a hole, but a place where light ends. It was proof not just of theory, but of reality. The image circled the world. It whispered, "Yes, I am here. You cannot see me, but you can see what I've done." And maybe that's enough. Seeing a black hole is like seeing the wind. You don't see the air, you see the sway of the branches, the trembling of leaves. Black holes sway. Stars, they bend light. They tug on time. And when we look closely, we see them by their effect. Even in our own galaxy, we've watched stars orbit something invisible. One called S2 takes 16 years to loop around a silent center near the Milky Way's heart, a heavy something, 4 million times the mass of the sun, yet perfectly dark, utterly still, but its pull is visible, its presence undeniable. So perhaps the lesson is this: not everything real needs to be seen. Some things are known by their gravity, by their silence, by the way they change what surrounds them. Black holes are like that quiet, unseen but certain, and as you rest now you can imagine that dark circle ringed in flame, pressing gently into the fabric of space. You won't see it tonight, but it's there, and in some strange way it sees you, not with eyes, not with thought, but with presence, a silent gravity that shapes everything it touches. But seeing is only the beginning, because black holes do more than exist. They influence, they sculpt, they sit at the centers of galaxies and hold their shapes in place. Could it be that they are not just ends, but anchors, not just collapse, but foundation? Let's go there, next to the heart of the spirals, the still center beneath the stars. There are moments in science that feel like poetry, not just numbers, but quiet awe in April. 2019, the world saw one of those moments, a blurry ring, a glowing outline of darkness, the first shadow of a black hole made visible not by light, but by its absence. This black hole lives in M87, a massive galaxy 50 million light-years away. It weighs more than 6 billion suns, and it had long been suspected seen not directly, but through the jets it launched the glow it ignited in nearby matter. But not until the Event Horizon Telescope, not until 8 observatories became one lens stretching across Earth did we truly see it. They gathered data in April 2017, radio waves, not visible light, and 2 years later the image emerged, a golden ring surrounding shadow light, twisted in orbit by gravity, glowing gas, circling an edge that cannot be crossed. What we saw was the photon ring light that nearly fell in but escaped after many turns. The dark center was the shadow of the event horizon, a place from which light does not return. Not a hole, but a shape, a border, a whisper of where the universe becomes quiet. Einstein's equations had predicted this image over a century ago, and here it was not just in theory but in the sky. The universe had followed the math. The picture looked back at us softly, not with menace but with presence, a place where time bends, where light folds, where matter ends, and yet, around that stillness motion, gas heated to billions of degrees, light swirling at nearly the speed of light, fury around stillness, chaos around silence. The image was grainy but profound, not proof of violence but proof of shape, proof that gravity leaves art in its wake. Since then, the telescope has looked inward to our own galaxy, to Sagittarius, a star, a black hole smaller than M87's, but much closer. Its light harder to catch its swirl, quieter its hunger gentler, but the shadow is there, and it too is waiting to be seen. And when that image comes, it will show us another ring, another center, another fold in the cloth of space. So tonight, as you lie, still imagine that ring in the dark, glowing softly from matter, not yet lost, circling a center where time stops. It is not a monster, it is not a mouth, it is the end of falling the edge of visibility, the place where gravity becomes complete, and in seeing it we do more than observe, we join, we witness, we understand, because in every beam of light there is memory, and in every shadow there is story, and the light that made that first image travelled 50 million years to reach us. It passed. Galaxies drifted through dust, crossed the cosmos, and waited for our eyes. It was a message, and we answered. But that black hole in M87 is not alone. Many galaxies have one at their core, even our own. Why do they live at the center? What role do they play? Are they endings or beginnings? Let's drift closer to the spiral arms and the silent giants that hold them. Galaxies spin their arms like ribbons, stars turn in graceful arcs, gas flows in luminous swirls. From a distance, they look like frozen whirlpools of light, but at their center is something still, something heavy, not a beacon but a shadow, not a fire but a fold, a supermassive black hole, millions or billions of times heavier than the sun. These are not the remains of stars. They are older, larger, forged from more than collapse. Some were born early in the universe's life, growing fast, feeding on gas, colliding with others, their gravity anchoring entire galaxies. Like the hub of a wheel, they hold the motion in place, not with ropes but with curvature. They shape, not by force but by presence. In our own galaxy, the center hides Sagittarius A, quiet, massive, invisible but not unknown. We have watched stars orbit it. One named S2 completes a full loop every 16 years. It swings close, then drifts far, held tightly by something it cannot see, something that bends space so steeply light itself curves away. We have measured this path precisely, and from it we know what must lie at the center. Sagittarius A is silent but strong. It is not consuming everything. It rests waiting, shaping, and in that waiting, it holds the galaxy together. It keeps the arms in motion. It balances the flow of stars. It is not destruction, it is structure. Some galaxies have feeding black holes, others have sleeping ones, but almost all have something at their core, and the mass of the black hole often matches the mass of the galaxy's central bulge. A quiet relationship, as if galaxy and black hole grew together, not one after the other, but side by side, companions in the making of shape. Some black holes lived fast in the early universe, glowing as quasars, lighting up the sky with jets and fire, even then less than 1 billion years after the Big Bang. Black holes already spun at the hearts of forming galaxies, suggesting they may not be endings at all, but parts of the beginning. Perhaps they helped galaxies form, perhaps they gathered matter-shaped orbits, regulated star formation. Perhaps without them, galaxies would never have coalesced at all. Perhaps they are both seed and center, birth and silence. Tonight, as you lie, still know that above you, the Milky Way turns, and at its heart, the black hole waits, not reaching, but holding, not devouring, but anchoring a gentle contradiction, a quiet center in a luminous spiral, a stillness that shapes the whole. And maybe now another question begins to unfold. If galaxies drift through space, and if many have black holes at their centers, what happens when two galaxies meet? Do their black holes meet too? Do they spiral inward? Do they merge? Let's drift toward that slow dance. Next, the one that ends with gravity folding space once more into silence. That the silence between galaxies is not empty, but full of motion. So tonight, let the stillness carry you to where two black holes drifted for eons, one born in a spiral galaxy, the other from a cluster far away. They circled slowly, without light, without sound, invisible yet inevitable. Now they spiral together. You don't need to rush. They never did. Their embrace is slow, but it changes the shape of everything. And as they merge, as their horizons kiss and become one, the universe asks a question. What happens to what's inside? To the stars they swallowed, to the light they bent, to the particles and pieces of everything. Do black holes ever forget, or do they carry memory in silence? Let's drift into that question, one even physicists can barely frame. What happens inside a black hole? Science can approach, measure, simulate. But this is the edge. This is a whisper wrapped in gravity. You've heard of the event horizon, not a wall, not a surface, but a threshold. Beyond it, escape becomes impossible. Light cannot return. Time cannot climb back. From the outside, it seems frozen. An object falling in appears to slow. Its light stretches redder and dimmer until it disappears. To a distant eye, it never quite falls. But to the thing itself, the story is different. If you were falling in, you would feel no sudden change, no jolt, no flame, just a silent passage through an unseen line. From that moment on, every direction curves inward. You cannot stop. You cannot return. Space has turned so deeply inward that all paths lead down. This descent is not just in distance, but in time, toward the center, toward the singularity. But this center is not a place. It's a point where our equations lose meaning, where the density becomes infinite and time itself folds. This is not a wall. It's the end of the map. Some say quantum physics may soften this sharp edge, that the singularity might not be infinite but strange, a structure we do not yet know. Others suggest we need a new theory altogether, something deeper than relativity, more complete than quantum mechanics. But until then, we float in the dark with what we do know. Once the event horizon is crossed, there is no message, no return. And inside, space and time begin to switch. Time becomes a direction, one you cannot avoid. It pulls like gravity. You fall not just in space, but into the future. A future that ends, always, at the singularity. Even light cannot choose otherwise. So what becomes of what falls in? A star? A spacecraft? A single photon? Is it erased? Stored? Compressed into nothing? This is where physics begins to argue. Quantum theory insists information cannot vanish. No state can be lost. It can be changed, scattered, disguised, but not destroyed. And yet black holes seem to do just that. All that remains on the outside is mass, charge, and spin. All else is gone. This conflict is called the information paradox. Some believe information is etched into the surface, the event horizon acting like a cosmic ledger. Others suggest it leaks out in Hawking radiation, slowly, faintly, over eons. And still others think we must change how we see space and time, that they are not smooth but woven from something deeper, a quantum fabric we are only beginning to glimpse. Black holes are not just objects, they are boundaries. Boundaries of knowledge, of language, of science itself. They remind us that the universe has depths we can feel but not explain, that some truths remain, hidden not in darkness but in silence. So tonight, let your thoughts drift inside a black hole, not as destruction, but as curiosity, not as end, but as fold, a place where space collapses and time flows like water, drawing everything inward. You cannot return, but it exists in galaxies near and far, and that is enough to awaken wonder. Still, another question waits. If black holes take in so much, do they ever stop? Do they ever let go? Do they end? Let's follow that quiet thread toward the slowest breath a black hole will ever take, toward its last. Black holes grow, that much is clear. They eat stars, they sip gas clouds, they merge with companions. When they join, they don't cancel, they add. They become heavier, deeper, stranger. Growth is in their nature. A black hole born from a star may be small, just a few solar masses, but if gas surrounds it, it begins to accrete. Matter doesn't fall straight in, it spirals, forming a hot disk that glows with X-rays before vanishing. This glow is how we first found them, not from the hole, from the feast. But there is a limit. Feed a black hole too fast, and the light it emits pushes back, blowing some of the gas away. This is the Eddington limit, the balance between hunger and radiation. It doesn't stop growth, but it slows it. Yet across millions of years, even slow feeding builds giants. Then come mergers. Two black holes spiraling together do not lose mass. They combine. A 30 solar mass black hole and a 40 solar mass one might become 68, with the rest transformed into gravitational waves. Not just mass, but motion. This is how we think supermassive black holes formed, step by step, merger by merger, at the hearts of galaxies. Now, some are billions of times heavier than our Sun, invisible giants, shaping orbits, anchoring galaxies. But even they do not grow forever. Eventually the stars grow stable, the gas runs dry, and nothing remains nearby to fall in. They rest, not dead, but dormant, waiting for another chance encounter, a star, a cloud, a wandering hole. Until then, they are silent. But there is another way black holes change, not by growth but by release. A whisper of loss, not loud, not fast, but patient. Stephen Hawking proposed that black holes leak, ever so slightly, that at the edge of the event horizon, pairs of particles appear, and sometimes one escapes. The result is Hawking radiation, a soft evaporation, a black hole losing energy, not with fire, but with breath. The smaller the black hole, the faster this happens. A mountain-sized black hole might vanish in seconds, but a supermassive one could take longer than the age of the universe to lose a fraction. Still, the truth remains. Black holes do not last forever. So, we arrive at an answer. Quiet. Subtle. Black holes grow. They wait. They merge. But in the end, they fade. Not with a bang, but with a long, slow exhale into the void. Imagine it. Trillions of years from now. Stars are gone. Galaxies are dim. But black holes remain. And then, slowly, even they begin to vanish, one breath at a time, until all that is left is radiation, until even that drifts. No rage, no explosion, just the soft release of gravity back to silence. So yes, black holes stop growing, not by choice, but because the universe goes quiet. Nothing left to eat, no light to bend, no partners to meet, just time and stillness. And when they are gone, what remains? What echo lingers? What ripple remembers? Let's drift there now, into the waves that outlive the source, to the motion that keeps going. Imagine a wave not in water or air, but in space itself, not shimmering, not flashing, but stretching and compressing. These are gravitational waves, ripples in the fabric of reality. When two black holes spiral and collide, they send out tremors. They move not through space, but as space, carrying the memory of motion. We first heard them in 2015, a soft chirp, a billion years in the making, recorded by LIGO, a delicate signal from a distant collision. Since then we've heard more, each wave a signature, each merger a fingerprint. These waves do not burn, they do not scatter, they pass through galaxies, through matter, through you. Right now, this very moment, you are being touched by waves older than Earth. You do not feel them. They are too faint. But they are there, always, and what do they carry? Not light, not heat, but information, a story of mass and change, a memory space refused to forget. A bell still ringing after the strike is long past. These waves are quiet, but endless. They may last beyond stars, beyond black holes, beyond galaxies. Some say the entire cosmos is filled with them, a soft background hum from countless events, all blended. The stochastic gravitational wave background, a sea of gentle whispers too faint to detect alone. But together they form texture, like rain falling far away. One day we may build instruments to hear that full chorus, lasers in space, stretched across millions of kilometers, listening for the deep notes, the grand collisions of giants. So tonight, as you rest, imagine floating on that sea. Not of water, not of sound, but of curved space. You are not just still. You are moving, drifting through ancient waves, through memories older than memory. Every wave that touches you leaves a trace, a quiet mark, a reminder that motion never dies. And now, one final question. What bends the space in the first place? What shapes the curves, makes stars fall, holds galaxies close? Let's follow the bend to the source, to the gentlest force that moves the world. Gravity. Not a push, not quite a pull, more like a slope, a tilt in the shape of reality. Right now, it cradles you in bed. It keeps you grounded, keeps the moon circling, keeps the planets dancing. Newton saw gravity as a pull, an invisible string, and he was right, mostly. His equations still guide rockets and tides. But then came Einstein, and with him, a new view. Gravity was not a force. It was the curve of space and time. Mass bends the fabric. Time slows near it. Light bends around it. Planets don't feel a pull. They follow paths in the curved world, like marbles rolling in a stretched sheet. This is general relativity, a new way of seeing, where gravity is the shape of the stage. You float in space. You throw a pebble. It drifts, not because it's pulled, but because it follows the curve. Astronauts orbiting Earth feel weightless, not because gravity is gone, but because they're falling with it. Gravity is not missing. It is everywhere. And though it is the weakest of all known forces, it holds everything together. It links galaxies, shapes light, predicts waves. Gravity is the soft architecture of the cosmos. And so, tonight, let it hold you gently. Let its curves guide your breath. Let the mysteries fold into wonder. Let the echoes of black holes, the memory of waves, and the shape of space lull you into stillness. For even in the quiet, the universe moves, and you move with it. Not by strength, but by stillness, not by force, but by presence. Gravity shapes the cosmos. It does not rush, it does not shout it, simply curves space and waits. And you may ask, why does mass bend space? What is space made of that? It can stretch and fold and ripple like cloth. The truth is, we don't yet fully know. Spacetime is a fabric we describe in equations, in measurements, in light, that bends and clocks that drift. But what it's made of at its core remains a mystery. Some imagine tiny quantum threads woven tighter than atoms, far beneath our current reach. That space itself might be grainy, that it might shimmer with fluctuations too small to see. Others believe it is smooth and emergent property of something even more abstract. But for now, we look from above, we trace the curves, we follow the rules that gravity has written, and we marvel because without it, there would be no stars, no planets, no moons, no time. As we understand it, gravity and time are joined in the deepest ways in strong gravity. Time slows a clock on Earth's surface, ticks just a little more slowly than one atop a mountain, not enough to feel, but enough to measure GPS satellites. Know this? They adjust for it, each signal slightly corrected, each calculation rooted in Einstein's insight. His theory lives not only in starlight, but in your pocket, in every map, every journey, and it lives in the stars, in the slow fall of comets, in the collapse that forms a black hole, in the steady rhythm that holds the universe together. Gravity is the reason night follows day, that galaxies spiral, and that atoms cooled into structure. It does not flash, it does not waver, it endures it, steadies, and tonight, as you lie beneath its pull, you are resting on a turning sphere because space allows it, because gravity invites it. You are not pinned down, you are held gently, part of a larger shape, guided by the curves of mass and time, and the black holes we've wandered near. They are only the deepest folds in that curve. Gravity exists everywhere, in your bones, in your breath, in the tilt of your head. And now another question rises. If gravity shapes all things, then what shaped gravity? What was before the curves, before the stretch, before even space itself to answer? We drift back beyond the stars, before the light, before the first atom into the hush that came just before time. The universe began in a moment, not an explosion, but a transformation, not from a point, but from a state, not a place, but an everywhere, a beginning, not of things, but of space and time themselves. The Big Bang, we call it. Though it was neither big nor a bang. It was sudden, yes, and hot, yes, but not loud. There was no air to carry sound, no edge to push against, just a rapid unfolding, a swelling of the newborn cosmos. In the smallest sliver of a second, the universe grew faster than light, in a process called cosmic inflation. It didn't expand into space. It created space itself like a balloon, stretching, not into something, but becoming something itself. And on that stretching surface were the seeds of everything. Tiny fluctuations in density and energy and shape, and in those irregularities, gravity found its cues. It would pull where things were thick, it would shape the contours of space, even then already present, not yet forming stars, but poised to gather, to sculpt, to wait. And for a long time the universe remained a fog, a plasma too hot for atoms. Light bounced endlessly, trapped by electrons. The cosmos glowed, but nothing could see. There were no eyes, no surfaces, no separation. Yet, as the universe expanded, it cooled, and at last electrons joined, with protons forming neutral atoms, mostly hydrogen, some helium, a trace of lithium, and suddenly the universe became transparent. Photons could travel, and did the light. From that moment still moves across the cosmos. We see it today as the cosmic microwave background, not bright, not colourful, but ancient, and stretched a whisper from the first breath of visibility, and still no stars. Just darkness, cooling gas, drifting under gravity's patient touch. Tiny ripples grew thicker, spots became clouds, clouds compressed into knots, knots grew dense under their own weight, until heat and pressure rose, and fusion began. And then the first stars flickered into brilliance, massive, short-lived blue-hot. The first lights in a dark sea. We call this cosmic dawn. And in those stars, hydrogen became helium. Helium fused into heavier elements. And when they died in fiery bursts, they spread those elements into space. Carbon, oxygen, iron, the building blocks of worlds and of you, the calcium in your teeth, the iron in your blood, the oxygen in your lungs were born in stars that shone before our sun existed. You are not descended from stardust as metaphor, but as fact and gravity. Did this gravity-gathered gas held, it still made the fire possible. And when those first stars died, they left behind something darker, black holes, and those holes began the next part of the story. And here the wonder deepens, because some now wonder if black holes existed even earlier, before the stars, before the galaxies, in the very breath of the Big Bang itself. Primordial, black holes, not born from death, but from birth, not from collapse, but from the pressure and energy of creation itself. If space-time trembled hard enough, in its first moments, parts of it may have collapsed into holes, without ever becoming matter, without ever becoming light. These black holes could be as small as a mountain, with the mass of a planet, or large as the ones we see in galaxies today. And if they exist, they are older than light, older than atoms, older than time, as we usually count it. Could they be real? Some scientists think so. Perhaps they are dark matter, the hidden mass that binds galaxies, the weight we feel but do not see. Perhaps they drift between stars invisible, except in their gentle pull. Or perhaps we've seen them already in gravitational waves, in strange collisions too heavy, too early to have come from stars, and if so, then the shadows were here first, before the light had even taken its first step. And if primordial black holes seeded the formation of galaxies, then every spiral, every orbit, every sunrise may owe its rhythm to their quiet gravity. And even if they remain unseen, their idea pulls at our curiosity. They remind us that the early universe was not only expansion and light, but also folding and silence, and perhaps some of those folds still remain scattered like hidden seeds of gravity's first thoughts. And this brings us to motion, to the way. Black holes find one another across vast reaches and spiral together, drawn by curves. Not choice they circle, They wait and they merge, but not quickly, not violently at first. There is a dance. Two black holes orbiting. Perhaps once they were stars born from the same cloud. Perhaps they burned near one another, then died and became more massive, more quiet, and gravity held on. It remembered. And now the pair circles again and again, not touching, but always closer. With every orbit, they lose a little energy, a little warmth, a gravitational wave, a sigh in space-time. And with every sigh, they drift inward. The spiral tightens, the motion quickens, the song deepens, and then suddenly or slowly, depending on your scale, they merge their horizons, blend their masses, join, and a new black hole is born, larger, smoother, more still, and the waves ripple outward like a bell ringing after the strike. And those waves reach us. We have heard them now many times. LIGO Virgo, KAGRA, listening, not with eyes, but with arms stretched across the earth, feeling the stretch and squeeze of passing waves, like listening for thunder from a billion light years away. And with each wave we learn of masses, spins, collisions, histories, some dances last eons, some only moments, but all end the same, in unity, in silence, in a deeper fold. And even afterward, the memory remains in the waves, in the shape of space itself. And this leads us back to the boundary, to the edge where our knowing ends, the event horizon, that mysterious surface, not a thing, not a shell, just a limit, cross it and light cannot return. Time bends inward and space twists around it. What lies beyond, no one can say. Not yet some think information is preserved, etched on the horizon itself. Others say it leaks back slowly in Hawking radiation, and still others believe the whole might connect to something else, a bridge, a tunnel, a fold into another kind of space. But we cannot look inside. We can only listen to the outside and wonder, and perhaps that is enough. Black holes are not mysteries to solve, but invitations to imagine they are, poems written in gravity, riddles etched in silence. They remind us that not all questions need answers to be beautiful. And so tonight, as you rest under the soft curve of gravity breathing, with the rhythm of a turning world, know this: you are part of that rhythm. You are curved too by mass, by motion, by time, and all around you, the universe curves with you. Stars spiral, galaxies drift, black holes merge, and even in the quiet, even in the dark, the dance goes on. And now, as your breath slows, let the questions slow too. Not ended, just paused until the next dream, the next drift, the next story. Let the cosmos cradle you in its fold, in its pull, in its silence and sleep, well under the weightless weight of everything.